Alright, in this lesson I'll introduce two additional parameters that are available on our string split method that'll buy us a few more options in the way that we can represent the data that this method returns to us. Let's begin by re-executing our code, and there we have our original data frame. So in the past two lessons we were able to extract the first name and the last name from our name column, and we did it both times by beginning with our string split method. Let's get to that point right now. I'm going to extract the name column, call str.split, and pass it a comma as my separator. And there you see at this point the method is returning to us a combination of lists for every value within this series. Now the first parameter that I'd like to introduce here is called expand. And by default it's set to false within the split method. But if we set expand equal to true, what it's going to do is return us a data frame rather than a series of Python lists. So keep in mind or pay close attention to how this data is currently represented. Let's take a look at our first row. We have Aaron as our first list item and L via J as our second list item. Whenever we expand this, we're going to get a data frame where those list values have been placed separated across multiple columns. And if we want to, let's say, assign these columns back to our data frame, we can do that. And the way we can do that is by using our equal sign. We know we'll have to do a call to our data frame or variable to the left. And usually when we want to assign a single column in the past, we've done something like this, like column name in double quotes in those square brackets. Now whenever we want to do something like this where we have two columns, what we can do is pass a list of column names in between those square brackets. So I'm going to call my first column here, which currently has a 0, I'm going to call it first name, and then comma, last name in double quotes. And what it's going to do is essentially a concatenation operation where it's going to match the index labels, because the index labels here are going to match the ones in our original data frame, and it's going to take this new data frame that's generated right here from this code and just add it to the right side of my existing data frame. So when I execute this and preview it with my first 3 rows, let's do the head method. You can see that to the right, those first name and last name columns have been generated, and they represent the result of the split method on my my original column, which is my name column. Now let's try another example with the same idea. Let's begin by taking out the position title series, position title with tab completion. Let's say I want to do a split here, and I want to do it with a space. So .str.split, so every time it runs into a space, the list is going to get another item. Here we have our regular result, which is the Python lists. If I want to see it as a data frame, I can do expand equals true, and we're going to see something very funky. We're going to get this very colossal data frame. Now why does this occur? Well, the reason for this is because there's a different number of spaces in every single department value. So whenever we have something like 3 words, we're only going to have 2 spaces. But whenever we have something like 8 words, we're going to have 7 spaces. And because it needs to split those long lists into all of these columns, the other ones that are much shorter have to have some kind of substitute values for all those columns that they have missing values for. So they're going to have none populated for all of the other column values. So you can see, for example, staff assistant to the alderman has 5 words, so that's able to be spread out. But something like water rate taker only has 3 columns worth of data, so it has none in the other positions. And the fact that we extend over here to column 8 indicates that there's some kind of massive large title that probably has 8 or 9 spaces within it, and that's why that split to accommodate for that large list spreads out all the way to the end. So we need some kind of way that we can limit the total number of columns that we're going to have in this data frame, because I don't want to add back 8 different columns to my existing data frame. Let's say what I want to do is limit this split to only 2 operations. So I want to have just the first word and then the remainder after my first occurrence of the space. Everything else that comes after that first space I just want to put as my second column value. I don't want to split it any further. So we have an additional argument that's available, or rather a additional parameter that we can pass an argument to, and that's n. And n is going to represent the maximum number of splits that we want to do. So, for example, if I put this as 1, that indicates that we're going to do one total split by a space. So when I execute this, you'll see that when we take a look at something like water rate taker, which is our very first row value, it's going to run into the very first space right here, and it's going to split at that point. And because we've set it to only split once and forget about everything else, everything that's the remainder is going to be represented in this second column. Similarly, if we have something like assistant to the alderman, it's going to run into its first space right after assistant, and rather than going ahead and splitting all these additional spaces, it's going to limit itself to the very first space. That's because we set n equal to 1, or one occurrence of our delimiter, and everything else to the right of that first occurrence is going to be what's represented in this second column. So now that I'm satisfied with this, I can add it to the end of my data frame. Let's once again do Chicago, square brackets to create a brand new column. In this case, we want multiple columns, 2 columns, so I'm going to add a Python list. Let's do first title word, and let's do remaining words. And we have to remember that equal sign at the end. Let's take a look at our first 3 rows. And we can see that now we've expanded as well as limited the total number of splits, and now we've added the results of that operation to the end of our data frame, much like we did with the first name and last name split. So that's a little bit more on the expand and end parameters of the string split method. I thought it was particularly helpful to dive a lot into the string split method, since it's one of the most common string methods that I tend to use in data frames. But that should cover everything that you need to know with the string split method, a really ideal way of separating string values by a common delimiter.